Welcome to the FNL podcast. My name is Vicky Denton, and I'm your host. Our guest today is Ali Erdemir. He's well known in the field of tribology. He's probably one of the world's most famous tribologists. He spent a long career at Argonne National Lab in the United States, and he became a distinguished fellow. And after he retired from Argonne, he became a professor and Halliburton chair in engineering in the mechanical engineering department of Texas A&M University. And today, Ali and I are going to talk about, guess what? Frontiers research on EV tribology. This is one of the hottest topic in our industry today. So I would like to introduce our guest, Ali, to the show. Welcome, Ali.
Thank you, Vicky. It's a great honor, great pleasure to have this opportunity with you. And we've been working on this podcast for a while, and here we go.
Yes, and we've known each other for a very long time.
That's correct. Yes.
Way back. And you're a fixture in our industry. And I guess, it's like getting you on the show is a real privilege.
Thank you.
So thank you so much for making the time to spend with us in this podcast.
Not at all. I think this is what we are for. We are all supposed to, help advance the frontiers of our field as best as we can and educate people and spread our knowledge. And that's, I think you're doing an extremely valuable job here, acting to facilitate all these things.
So, Ali, let's start on the topic. Now, EVs are not new. I mean, electric vehicles have been around for such a long time. Why is it that we don't know everything about EV tribology?
That's a very good question. It has been there, but for quite a while, we didn't really know if the EVs would explode the way, they did in recent few years, actually. And until then, we did actually have some research related to the EV, especially plug-in, hybrids type of EV. But now the switch is actually toward the full EV, full battery-powered, EV vehicles, in which we have all these, different type of electrical motors retrofitted to actually provide very smooth, very high power operations in these vehicles. So with that, the situation or the tribology conditions became a little bit more important and a little bit more challenging. So with that challenge, we have to actually look to see if we can overcome all these remaining, challenges and issues and make the EV the transportation of the next century and beyond. They are very clean. They are extremely, efficient. And, there's a huge potential there. I think this is the new paradigm, in my opinion.
Now, Ali, when we hear people talk about EVs in our industry, obviously as a replacement for the internal combustion engine, people get very scared. They think that if EVs were to take over the world, most people would lose their job in our industry. The demand for lubricants would dwindle. Do you share that opinion?
I mean, we should not be really worried about losing job. I think the industry will transform to a different, form. Actually, they are doing that as we speak. The requirements for EV fluids are somewhat different from the ones that we have been using in IC engines. But these fluids, these lubricants will always be there. I mean, without the lubrication, you cannot think of, motion, especially mechanical motion. So there will be need for that. in this area. The big question is that can we actually develop the next generation with very high value added, in the form of high value added products, and that will still keep a lot of jobs alive. I mean, somebody has to do the research, somebody has to do the testing, somebody has to, manufacture. All these things, I mean, create even maybe even more jobs. We should not really be worried about with the switch to electric vehicles, some of the lubrication jobs will disappear. I mean, in the long run, it might happen, but at the moment, I don't see that's happening. I mean, none of the big lubricant companies or additive companies actually started laying off their people because, now we are switching more and more into electric vehicles.
So tell us, what are the most critical issues today that we know with EV lubricants and fluids and greases?
Yeah, I mean, of course, EVs operate in a different type of, different way than what the internal combustion engines have been, operating. I mean, with that difference, actually, we are seeing some materials compatibility challenges or issues, for example. And in the fluid sides, we have electrical conductivity challenges because you always have some stray electricity, passing through your system. And when and if this electricity, discharges through these tribological interfaces, there's always the danger of, damaging these surfaces without even causing, any type of other problems. And then we have the thermal management challenges. I mean, you have batteries, you have motors, you have all these sliding interfaces, and these actually generate quite a bit of heat. And that heat needs to be, dissipated. If not, then the, rheological properties of these fluids will be greatly influenced. And then on top of that, we have new tribological challenges. The operating conditions of EVs are slightly very different. I mean, it is sort of shifting from fully, mostly hydrodynamic to hydrodynamic or boundary type of, sliding regime. And these would increase the, demands on gears, on bearings. These would potentially be sliding more under boundary conditions, and with that, you can actually expect wear. You can expect increased, micro pitting, all these other problems that we are know of, based on these kind of severe application conditions. So application conditions are getting tougher, much more severe than what it used to be in the internal combustion engines. On top of that, of course, the lubricant companies, the way I see it, trying to develop the lowest viscosity fluids for these very severe applications. Of course, that low viscosity fluid means you are further, exacerbating that contact, pressure and sliding conditions or rolling conditions. With that, you might expect even far more, dramatic increase in wear and pitting and all these other, problems that might actually come with that very severe, contact situations.
Yeah, you mentioned three different kinds of lubrication regimes. Explain it to us.
Yeah, absolutely. I mean, this is the, genesis of the very well-known, Strybeck curve. It has friction coefficient in the y-axis. Then you have in the x-axis viscosity times the velocity divided by load. And in most of our IC engines, your systems, especially powertrain, actually operate under full hydrodynamic or mixed lubrication regimes, in which sliding pairs actually occasionally come into contact, and in fact, sometimes they don't even come to contact. There's a gap of lubricant film that separates the surfaces apart, and then there is no contact, there is no wear. But under boundary conditions, you actually have very thin lubricant film where metal to metal surface actually tends to dominate. And that's when actually you start to get these, wear particles generating, wear becoming a major issue. And this is very typical of, for example, tappets and gears and things like that, even in IC engines. But it looks that these regimes, these boundary lubricated, sliding situations, will be far more common in electric vehicles.
And why is that? Explain to us why there's more boundary lubrication occurring with EVs than with the traditional
Very good question. Very good question. With the EVs, actually, we are changing the operating condition from mostly load carrying to torque transferring, type of operation. In the IC engines, it's mostly load carrying type of function that the lubricant provides. But in the case of EVs, it is more actually transferring the torque, and especially under lower sliding speeds, you have very high torque, and with that high torque, actually you create these very severe metal to metal contact situations.
And what's the solution that the tribologist would typically apply for a situation like that, where you have more torque, you have potentially more wear?
Yeah, I mean, I think that's a very good question again. The way I see it, the companies are now trying to develop more effective, additives, for example. Under these metal to metal contact, you need different type of or more effective, anti-friction and wear additives, extreme pressure additives, anti-scuff additives. I think these are becoming far more important. And of course, maybe in order to enhance the wear durability of these surfaces, one can also have to do engineering on the material side.
Okay, let's talk about the typical anti-wear extreme pressure additive chemistry. For the traditional ice, what are the chemistries that are typically used for these kinds of additives?
I mean, there are two kinds, as you know. One is the ZDDP, which is used for controlling wear. And this chemical has been around for maybe more than 50 years, and actually it works extremely well. And the other one is used for anti-friction, which is MODTC, molybdenum dicarbonate. And these two, when present in the lubricating oil, actually forms a very effective, boundary film on the surface. And that boundary film not only, lower or reduce wear, but also provide low friction. These two are kind of very important in terms of, overcoming friction and wear-related problems.
Now, Ali, currently though, there's a limit on how much phosphorus and other chemicals you can include in your formulation, right? Because under the specs that we have, well, at least there's a chemical box that or chemical limits on some of the chemistries. Um, so, would that have an impact on the 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 EV formulations that
I think that here, the situation with high C engines, they've been reducing the amount of ZDDP or phosphorus sulfur from the oils, mainly because these two elements can adversely interfere with the after treatment devices. the catalyst, catalytic converters. Now that we don't have an internal combustion engines, maybe it might be possible to actually maybe slightly increase or optimize the concentration of these additives to provide their full potential in terms of friction and wear. And also it could be very important to look into some other or more effective additive packages. Maybe even ionic liquids could be very important in these kind of applications. There could be some other chemistries actually that might work equally or even better than existing additives. These whole things I think should be searched again, and in the end, hopefully, we will have better chemistries, additive chemistries that can circumvent all these, problems due to the new operational conditions of these, driveline systems.
So Argon actually has done a lot of research on ionic liquids, right? Where is that material today? Is it being used commercially in formulations?
To the best of my knowledge, I don't think there is a formulation. Of course, companies kind of don't reveal the exact composition of their formulation. But I'm not aware of any company actually using ionic liquids. I think part of the problem could be the very high cost of these, additives. And of course, traditionally, these additives have some other problems, related to their very unique chemical structures, being somewhat hydrophobic, also triggering unwanted, maybe corrosive, effects and things like that. But I think with the new reality, we should revisit all these additives and maybe optimize, repackage it for these kind of application conditions. And I think that was probably one of the reasons why they haven't really penetrated into the, conventional engine, applications, because of the fear of, accelerated wear, oxidation, and all these other things. Of course, you also worry about water vapor interacting with these, additives. And also cost. I mean, here, because of the very important function of these mechanical systems, bearings, gears, maybe the cost may not be that important. After all, you want to save these components and make sure that they will, last for the lifetime of the engines or these vehicles. Actually, there is no engine in electric vehicles, of course.
You also mentioned one more thing, Ali, earlier, which is new materials. What are the new materials that a tribologist would have to be faced with electric vehicles that didn't exist under the old ICE engines?
Yeah, I think higher hardness on these surfaces would be a good thing. That will increase the wear resistance or pitting resistance of these components that are rolling or sliding. And then that surface engineering to maybe provide a different type of load transition from contact interface way into the substrate or the component will be a very important thing. Even some coatings could be actually considered as a sacrificial layer, especially during the running in period of these gears and bearings and things like that. And using these well-developed nitride or carbide or diamond-like carbon type of coatings that we actually explored quite extensively might be a little bit challenging because of the very curved surfaces of these bearings and gears, or it can also add to the cost, of course. But in the end, if needed, these technologies could also be used. And most of these, especially the gears, are already being heat treated or sometimes even, carburized or nitrided, for example, to provide, longer wear life. I mean, those things could also be made far more, available to these kind of applications.
Battery electric vehicles are heavier, right, than the ICE engines, at least for passenger car, uh, for sure, and maybe even heavy duty. Um, with that kind of weight, does that have an impact on how you lubricate the entire vehicle?
It definitely does. I mean, vehicle weight actually would uh, add extra stress to these interfaces, bearing interfaces where motion comes to life. But I'm very hopeful that in the long run, the batteries will be much lighter. In fact, that's one of the major research thrusts at the moment with battery manufacturers and all these, scientists actually doing the real research in there. In the long run, I'm very hopeful that some very lightweight, batteries would be developed. Or some of these would actually scale down in size, yet provide same level of, power. With that, you would also, reduce the weight. But we are not there yet. So, but in the long run, I'm very hopeful that these things would be. Of course, some of these EV manufacturers are looking into much lighter weight materials than what the IC powered, vehicles have been using. They are looking into, composites, for example. They are looking into even polymer-based, composite materials to further lighten up the weight of the overall weight of the electric vehicles. So there are some still possibilities to actually lighten up these vehicles as well.
Uh, Tell us what the thermal challenges are. We talked a lot about the tribological challenges. On the thermal side and the electrical side, what are the key challenges that you see?
Yeah, I mean, unfortunately, current fluids do not necessarily have the level of thermal conductivity that we probably need. I mean, this is one of the major areas most fluid companies or lubricant companies are working at the moment to make their fluids actually more thermally conducting so that the heat doesn't build up. And actually, they are trying to make these fluids as increase their heat capacity so that they can actually act as a coolant. That cooling is done with glycols and other type of things in conventional engines, but now that burden is also being transferred to the fluids. So there's a lot of activities, ground up, research going on to make develop new chemistries which will allow higher thermal conductivity with lubricants. Lubricants now has to have not only very good lubricating properties, but also they should have very good, thermal conductivity, and also should have very high electrical breakdown, resistance. It's these are the kind of challenges I think that will shape the next generation of fluids for electric vehicle applications.
Now, when you talk about thermal conductivity, would that be a function of the base fluid or the additive?
I mean, additive is a smaller portion of the whole package, and it will be still, I think, pretty much burdened on the base fluid.
And and,
Uh,
and from your perspective, what seem to be the most promising base fluids that could provide the cooling that's required by
I
EVs?
mean, by and large, these water-based, lubricants, glycols, are known to be very good, thermal conductors. There are some other fluids. I mean, PAOs actually could be made more thermally conducting. And I'm not quite sure about the mineral-based oils, but I think there are possibilities to dramatically, improve the thermal conductivity of these fluids. I mean, the lubricant manufacturers already, developing fluids actually, which seems to have pretty decent, thermal conductivity, ratings. And I think these would be further optimized in the coming years. And then we would really have a very good fluid meeting the requirements of these, EV applications.
Yeah, we've heard a few stories where EVs catch fire. Uh, is would lubricants or fluids make that less of a possibility if we're able to develop something that would, um, that would be have a cooling effect? I mean,
Yeah, that's a very good point. I mean, they could be. You know, but now with the hydrocarbon, backbone, in a fire situations, I think all of these fluids will have a limit in terms of, they will have flash point, for example. That flash point could be actually further increased, maybe. At least these molecules or these fluids will not aid or further accelerate the fire, but they would not necessarily cause any problem in terms of, uh, spraying, fuel on a fire, but rather spraying water on a fire type of situations. I think those can be done. Maybe that might require a different type of additive as well, but these are all new, challenges. I think that will be worked on in coming years, and I'm very hopeful with the wealth of information and the research capabilities all these companies have in the additive and the base oil area. That will lead to some very good fluids with very good thermal as well as electrical and tribological properties. That's what I'm very hopeful.
now, what makes life easier for the industries when you have a standard that would be basically the minimum requirement? None exists right now for electric vehicles. Do you see that coming?
Actually, yes, you're absolutely right. ASTM, SAE, API, I think they are all aware of these. And uh, uh, and working on it. I know that some of my colleagues involved in the ASTM standardization already looking into these kind of things. Developing new standards that can be used to check the quality of a fluid, not only from a tribological point of view, but also from thermal, electrical, point of views.
Do you think people in our industry are smart enough to be able to create a fluid that does everything for an electric vehicle?
I think so. I think that will be the ultimate goal. People are working on it, and they are saying that a single unified fluid capable of providing everything you need for a field for life capability. And that's the dream fluids. I mean, I don't know how many more years it might take, but with our vast, chemical knowledge, chemistry, chemist, physicist, all these people, and now of course we have these very advanced, computational capabilities using artificial intelligence and machine learning. When we combine all these things, there might be a magical new molecule that might actually ultimately provide all these things that we dream of.
How important is the carbon footprint of the materials that will be used in the future for EV fluids and greases?
I think carbon footprint will be very important, not only for the materials, but also the fluids, and also operational requirements of all these, electric vehicles. It will be always there, and of course, you will actually be getting rid of exhaust, emission uh, um, from an IC engines. But if the electricity used to power the electric vehicle comes from a fossil fuel burning power plant, then you were just going to be shifting the burden from the vehicle to the source of the energy where the energy actually is produced. So I think for one thing we have to adapt the best practices in terms of actually, we have to look at the whole things from a life cycle analysis type, point of view. Every single steps, we should try to eliminate the sources of, greenhouse gas emissions, and also improve the efficiency of these operations. And then, when the vehicle rolls out to the road, we have to also make sure that that vehicle actually give rise to the least amount of CO2 emissions, and also provide the utmost, efficiency.
We already see some renewable base oils in the market. Will we see renewable additives in the market in the future?
There could be. There was an electric vehicle Tribology workshop in San Antonio back in November, I believe, where I attended. There were several companies actually coming from the renewable type of products. These are even what they call green lubricants, derived out of the plants, or vegetable oils. Um, I mean, that is possible. They tried it in the IC engine applications, unfortunately, because of the not so desirable, thermal stability and oxidation resistance of these oils. They did not necessarily make a big impact. But here we don't have combustion, engine or internal combustion engine. Maybe this could be a very opportune, application for those kind of, technologies or products.
So, I think I've covered everything that I can think of. Um, is there something I missed, Ali, that maybe we should touch on?
In summary, I think there are a lot of opportunities in the fluid sides as well as in the material sides. So these are very good things for researchers like me. I think these are easily surmountable. Easily we can easily overcome these problems. We are right in the beginning, but given another 10 years, I think the vehicles made out of these, electric motors, electrical vehicles will be a real, thing, and will help our environment, will help our energy crisis, will also add to our ultimate goal of a sustainable, planet. I think that's the most exciting part, in my opinion.
So right now, though, uh, most of the batteries, correct me if I'm wrong, for passenger cars use lithium battery. Um, Based on your experience, what do you think? would be the most, not only ecologically, but also most efficient and available uh, battery in the future?
That's a very good question. I think the major focus at the moment to increase the driving range of these vehicles, and that comes with the high power, high capacity batteries, and also very quick, charging capabilities. And of course, more availability in terms of infrastructure of these charging stations. I think those are all evolving. But in the heart of the battery technology, you're absolutely right. While trying to solve our greenhouse gas emission problem, are we also creating some other environmental problems? How we can actually handle all these batteries once the vehicle actually reach its ultimate lifetime, or these batteries actually are useless anymore. And at the moment, there's a huge interest and activities actually related to recovery and recycling of these batteries. And so that lithium you mentioned, I think, will circulate uh, uh, again and again, and will be recovered very safely out of these used batteries and put in the new ones. And I think that's
Do
yeah.
you think the world will run out of lithium eventually?
Well, that's a good question. It could. I mean, the if we switch 100% to EVs, we're talking about more than 100 million vehicles, or even 100, maybe 20 million vehicles per year. And at the moment, we have over 1 billion vehicles actually on the roads. So, with the increasing population and demands for all these cars, you're absolutely right. I think lithium is going to be a hot commodity in the future. Whether we can keep actually discovering new deposits that can provide meet our needs for lithium. But I think this recycling and reusing is a very important thing. This is also very much in line with our drive to generate this circular economy, not only in this kind of things, but everything else that we do, including plastics and whatnot.
Well, Ali, thank you so much for sharing with us your experience and your knowledge. And we wish you well in your research. And keep in touch. Let us know what you're working on, because we know whatever it is, it's going to be the future.
Thank you, Vicky, for giving me this opportunity. Greatly appreciated.
Thank you as well. Have a great day. Bye
You
bye.
too. Bye bye.